Hello, yeah, I'm Dom. I'm a principal software engineer at the BBC. I've been at the BBC for around 6 years now. In total, in TV for 4 of those years. Previously, I was only focused on like TV playback, and there was a question around the trials and tribulations of getting playback working. That was my life for a good few years. And then more recently, I've been across kind of the whole iPlayer application, and we did a big rebuild recently. This is me showing the boss how to use a TV. Tough customer. So a little bit, hands up if you've heard of iPlayer. Good, you're in the right room. So yeah, a little bit here just because some stats, why not? It's the fastest growing VOD service in the UK. So that's compared to the big boys like Disney Plus and Netflix. We get around 14.1 weekly active accounts. That's kind of a very BBC metric, but it's what we capture. And that totals around 54.4 million weekly hours streamed. So we're talking big numbers, 8 billion stream requests per year. So we are competing in the UK in particular against those kind of titans, the YouTubes, the Primes and stuff. And of that, 3/4 of it is TV. So we are definitely the biggest of the platforms. In terms of our foray into TV, so I mean, previously iPlayer launched famously on Christmas Day for the kind of desktop client. We started to play around with TVs in around 2008. History here is a bit shaky. Not a lot of people still around probably realised TV is hellish and left. But we kind of started playing with Virgin devices. Then we did some stuff with BT. Now, and then Sky, and then the Wii. We had a weird channel integration and PlayStation 3. And we're now at a point where we've got around 600 different device configurations. And I'll talk a bit about what device configurations are later, but it's kind of like variants of devices essentially. And our support goes back to 2013. We've only just ditched the kind of 2010, 2012 devices. They just became untenable, but we're still supporting 2013. So if a TV came into the UK market from 2013 onwards, you can pretty much guarantee it'll have iPlayer on it, or will have had it at some point. So this talk is mainly around considerations when building an app for TV, and it fits nicely with Tom's, but possibly more from the kind of engineering perspective and what we do to get this to work. So as all good TV talks start, I want to talk about the fractured market. I've not got as nice a slide. You can tell Tom's got some branding people. But I want to start with our colleagues over in mobile. So the iPlayer app has an Android client and an iOS client. I've kind of put Fire OS there. It's the sort of cousin to Android. You just have to consider a few extra bits there. But in mobile, you're thinking about two things, two platforms. You're either writing a Kotlin app, you're writing a Swift app, or you may do something like React Native. And that's relatively simple. In desktop, it's a similar-ish story in that you're designing for a few browsers. You've got Chrome, you've got mobile Safari, they're your kind of big, that's where most of your users are at. You've got some newcomers, Brave and Arc, that have come in the last few years. They are gaining popularity. But we all know, really, they're just Chromium under the hood, right? Shout out to the Firefox users. I think there's a couple of you in, probably all of you. But a lot of the time, these people are developing, these days particularly, for evergreen browsers. So they're targeting the latest browser version, maybe in a couple of versions back too. Gone are the days of having to think about Internet Explorer updating with various versions of Windows. You having to think about IE9 and 10 and 11. You're pretty much designing for Chromium these days. So then you get to TV, and this is nowhere near as nice as Tom's snazzy slide, but all TV talks got to have a logo slide. This is mine. But this is genuinely the language that we talk about. If you come to Salford on a Wednesday, you'll hear TV developers talking about these things. We are often debating around won't slag them off, but some of them devices on there that aren't the best. And we're also talking about kind of devices and all the different form factors they come in. As we mentioned, you've got all these devices come with different hardware constraints, but they also come with different inputs. So you've got your TVs, your set-top boxes, your kind of streaming sticks like your Amazon Fires, games consoles, and even your more kind of weird and wonderful, so projectors have now got smart features and kind of stand-by-me monitor things, I'm not sure who's buying them, and smart home screens and all that kind of stuff. A lot of them are now built with smart capabilities in them. And then when you go a kind of level down, you've got to think about all the different operating systems these have got. We've got our Android and kind of iOS equivalent with tvOS, but we've also got Roku, TiVo, Tizen, RDK, all the various versions of Linux that are supported. So it begs the question, how on earth do you start thinking about creating an application for TV from a technical point of view? What technology stack do you need to use? And the first question, as Tom said, is you've got to really figure out what users are you targeting. If you're developing an application that allows people to stream, watch their favorite gamers stream online, you're probably going to be thinking about games consoles, maybe an NVIDIA Shield. These users possibly have more money that they can spend on like AV or want to invest in their AV setup. Whereas if you're developing an app that maybe is going to surface the very best in nature documentaries, you might be skewing to the older demographic. And there might be some crummy Humax device dusting away under a TV. So you've really got to be thinking about what devices are you targeting, what users, and therefore what devices. And that can then help you determine your technology stack. Once you've kind of gotten your head through that, you've then got a whole bunch of tensions. And these are stuff, again, that we are constantly debating and talk about inside the iPlayer teams. At the top there, you've got UX, and that's all the stuff Tom says. You really want to make that kind of hit those points of delight. But you've also got your kind of accessibility requirements and things. We want all that snazzy stuff that Tom showed of kind of auto-expanding trailers and multi-screen and all that kind of good stuff. But it comes at a cost, and it comes at a kind of tension with reach too. There's no way you're getting that working on a 2012 device. You've got to make a very distinct decision. Are you willing to kind of have an app that is the same across all platforms, so your 2012s or your 2013s and your 2025s, or are you going to have maybe a gold, bronze, silver experience? And the same for cost. What's your engineering kind of resource look like? Are they native developers? Are they web developers? Have you got BrightScript developers? All these are things you've got to consider when thinking about building a TV application, and they're always at loggerheads with one another. So what do we do in iPlayer? So our strategy for the last however many years now has been a single application. Asterisk at the bottom there. Apple TV not included. Due to platform constraints, we don't ship the same application to Apple TV. But we do for all the others. So all them other brands, it's all Apple TV. It's all one application. And to do this, we use the web. That's our platform of choice. And it's kind of tried to be that, it's tried to do what Java couldn't, right? It's that write once, run everywhere. And for the most part, it allows us to really dedicate on being the browser being that runtime of choice, meaning we don't have to really think about the hardware. We don't have to think about the operating system. We just use those three lovely tenets of HTML, JavaScript, and CSS. And it all just works. Thank you, the end. Not so fast. TV browsers. If you've ever done anything with browsers on TVs, you'll know this is an absolute pain. It isn't the dreamland of consistency we thought. We actually have to deal with the real Edge and the real Opera, not the Chromium ones, the really kind of sucky ones. And for the most part, TV manufacturers are taking a browser, they're looking at their TV and going, this doesn't quite fit. We've got a dual-core processor, we've got a gig or two of RAM. We kind of need to take a browser off the shelf and squeeze it into some shape that will work on their TV. And then if you think about over the many years that they've done this, TVs are often stuck at a point in time. They're released in 2014, and then they don't get changed since then. Samsung aren't thinking about 2014 TVs anymore. They're now on 15, 16. They're about selling units, not necessarily supporting previous ones. Or they'll give a certain level of support at least. And we're seeing this in our data that actually users are sticking with those older devices. They're not upgrading like people upgrade mobile and desktop. So this is our kind of spread of where users roughly sit on years of devices. 2016, I mean, it might coincide with when a pretty famous Fire Stick came out, but that has got a lot of users still. That's a nearly 10-year-old device, and it holds a huge amount of users for us. Even 2020, it's like nearly 5 years old, and people just aren't upgraded as often as you'd kind of maybe hope, but expect. And this causes us problems, right? Some of these devices, particularly on this side of the graph, sometimes you need a USB to update the firmware. So you're not getting a new browser very time soon. And then once you've kind of thought through all that, what operating system am I targeting? What device am I targeting? What browser do I therefore get given? You've then got all these other aspects to think about when you're thinking about TV. All these various very TV-specific specifications, dbook, HBBTV, OpenIPTV. Are you doing any integrations with Freely now? Getting playback to work through Dash or HLS? All these extra things that your kind of standard web developer who's living in the, I don't know, ECMAScript, CSS working group, HTML living standard, you've got to take all that stuff and apply this on top. So here's kind of how we roughly do this. So I've kind of come up with this concept of the three C's. It's not a term we use, I just made it up for this talk. But the first one is compile. So we had a long-standing kind of rule in the department in iPlayer and TV that we would write to the lowest common denominator. So we used to write ES3 and ES5 JavaScript. And for a long time that kind of worked, but over time that does become a bit of a mess. The code base became a mess. It was hard to recruit for and hard to retain like good talent with. Devs just want to write and use modern tools, right? It's as simple as that often. So we now kind of have a strategy where we compile to a code target that the device supports. And to do that, we're essentially talking about transpiling and polyfilling. And we're targeting, so this, it's rubbish, it's a code snippet, right? But what we're saying here is we're using industry tooling. We're relying on the best practices of web development from the industry, but they've not got a slant on TV. They are thinking about desktop browsers for the most part. So what we're aiming to do here is get as close as possible to something that will work on TV. So these targets are actually referencing, so Chrome 32 is a browser that came out in 2014. So we kind of feed this information into these tools. It will then spit out a version of our code that will roughly work on 2014 desktop browsers. That gets us pretty close to what we need, but it's not perfect. We then rely on a lot of polyfills to get through things. But even there's problems. So essentially there's performance problems with polyfills. You're taking something that runs natively in a browser in C and you're replicating it in JavaScript, a single-threaded kind of language on a dual-core processor. A lot of time you're asking for trouble. So we've kind of got this concept of an allow and deny list for polyfills, where anytime a developer adds a new feature to the code base, the tool will ask you a specific question. It'll stop the build and say, "Are you sure you want to add this polyfill?" And that kind of, it's a point in time where we'll stop and test it on some devices and make sure we don't hit those performance concerns. So at the top there is just an example of like a couple of allowed polyfills we've got. We've also got this block of included polyfills. Because that target list only actually gets us to 2014, and we have 2013, and for a period we had even older, we have to force some polyfills in. So like this one here was because for whatever reason, what a device or two, the parseInt function just did not work unless you gave it very specific parameters. So we just now force that polyfill in and it kind of makes things happy. On the inverse of that, we found like severe performance issues with some polyfills. So we have a very specific excluded list where even if a developer uses that functionality, we will never include that polyfill because we just know it causes issues. Your phone's in your hand. That brings me on to the second C. So this is certify, and we talked about certification, but actually I think the certification process Tom was talking about is when you are submitting an application to a store. What we talk about certify is kind of certifying the runtime that the kind of TVs give to us, so the browser that the TV gives to us. And this is around ensuring that devices can run your application. That sounds really straightforward, but it's slightly tweaked, it's slight inverse. Usually you're ensuring your application runs on a device. What we do is we test that the device can run the application. Your application is a moving target. We're doing 5, 6, 7 releases a day of our application. There's no way we can bring in all 600 different configurations and try run that, try test that. So instead what we do is we atomically test the runtime. We have small test cases that are prodding the browser environment. So this test here is looking at whether this device supports the fetch browser API and then whether it can support a cause post request. We've built up like 100 or so of these tests now that we can run on a device and basically assert that this browser is fit for iPlayer. And to do that, we have a tool called the Automated Certification Tool. This is a really cool tool. It probably deserves a talk all of its own, and I'll try and get someone to do this one day. But essentially, it allows a developer and a tester to pair their laptop with a TV and then run through those test cases. So you can select if you want to try service workers or the fetch API as mentioned, or some web audio stuff, and you can run a suite of tests and it'll report back to you whether they passed or failed that test, and if whatever has occurred. And what we ask manufacturers to do is actually run these tests themselves during their kind of design and research and development process. Knowing that they're releasing TVs every year, we're encouraging them to run these tests early so that when they submit them to us for certification, we can kind of be pretty confident they're going to pass, or they can be pretty confident they can pass at least. So yeah, as mentioned, we're in a very luxurious position at the BBC in that we ask manufacturers to send us their devices to kind of certify. So we have a team, full-time team in the office 5 days a week, basically getting new TVs and Fire Sticks and all the kind of bits and pieces sent to us, and we'll run those ACT tests on them and kind of rubber stamp whether that's an acceptable runtime for iPlayer. Very different to the world FX are in and stuff where you're submitting through app stores. We're kind of on the inverse of that. We say yes to them. But it all works because of years and years of relationships we've built with partners. They're incentivized to have iPlayer on that platform. It helps shift units, and we're incentivized to give our users a really good experience. So it kind of works. The last C is configure. So this is how we get around the fact that there's some 2025 devices. They've got all the kind of power and processing, and they can support all the snazzy browser APIs in the world. And then we've also got to support the 2013s. So we have this ability to capture our device capabilities, and that's in the form of a device configuration file. It's basically a JSON file, one per device. So this is where the 600 number comes from. It's one per kind of device or variation of a device. And it essentially details what the device's capabilities are. So an example would be what kind of playback it can do. Does it support media source extensions, or does it require a native player? If it's a panel device, does that panel support UHD? What kind of animation? All these kind of things, and we build up a picture of that device. Then when a user loads the app, this is the first thing that happens. We go and fetch that config. And then during runtime, the program, the application can basically query that config to determine what kind of thing to do. So it basically figures out, oh, this is an MSE device, I'll go grab my -JS player. This is a native device, oh, I'll go grab the native player. And the same for like things like UHD, etc. And this is really powerful. It has its downfalls, because we've kind of exploded that variance of the application, but it's incredibly powerful. It lets us do things on 2025 devices that we can't do on 2013 devices. The other one is flagpoles. Lots of terms for these in industry, I guess dials, blah, blah, blah. Lots of times these are used for operational things. You've got some sort of back-end issue, you want to turn something off to kind of keep users able to use your app. We use them for that, but we also use them for rolling out new features. So we've redesigned the new hero, we want to roll it out to devices, but we simply don't have all devices, or we certainly don't have the time to test them all. This is our ability to roll out a feature behind a feature flag, turn that on, gather some information about whether it works or not, and then turn it off if that's an issue. This is another really powerful thing that allows us to kind of move quick in this ball of mud of TV devices. And lastly in this section, device experimentation. So we also have this notion of being able to run, similar to the ACT test, some atomic assertions on the device at boot. But instead of ACT where we are sat in front of the device and running the test, these are running on users' devices. So when you boot your application, you'll get the splash screen, and behind the scenes, this will be running some experiments for us. And that experiment will return some information to a central server, and then we can pump that into, this is kind of like a copy of can I use sort of thing. So here we're like, in this example, we're testing for the intersection observer API. So this is something we wanted to use. It's really useful for knowing when things have entered the viewport. So for us, it's around stats. We want to know, has a user seen this thing, and then we can send the stats for it. And a lot of it relies on this intersection observer API. So we wanted to know what devices can support that. So we wrote a little experiment. Like I said, it runs at the boot of the application, then reports back, and then we can pump it in. The question marks are where we've not had data back. So usually we run these experiments for like multiple weeks until we've got a good enough picture to know whether we can use that API. And then what we'll do is we'll feed that information into those device configs. So it'll form part of that blob. So at the runtime of the application, it'll say, yes, this device can support intersection observer, therefore use it. Where we still struggle. So it takes time to write ACT tests. Every time you're writing ACT tests, you're not doing product development, which is hard. This is just a random picture of all the devices in a store cupboard somewhere. It needs cleaning. We haven't solved CSS yet. I think it's the biggest pain point still in our development process. We're able to use kind of modern tooling in terms of JavaScript and semantic HTML and stuff, but CSS, we're still CSSing like it's 2010, and that is painful. No Flexbox, no grid, nothing like that. And we're still seeing random occurrences where things will render differently across devices. So I'd say for me, that's definitely our biggest pain point. As I mentioned, polyfills can cause performance issues. Be very careful about how you transform your code and try and get it running for environments because, yeah, you can often make it worse. Sometimes devices will tell us they support things when they don't. So we had a case where we had a test case looking for a certain function being present on the window that we ran it on the device, it passed, cool. Well, but the function was actually just returning an empty object. It didn't actually do anything. So the manufacturer had done a sneaky, made the test pass, but not actually done the implementation. So often we'll have to kind of go back, and it's a bit late in the day to find that sort of thing, so we'll have to go back to them, or we'll try and make that test better. But yeah, devices will lie. Often it's because they've had to squeeze, like I said, squeeze a browser onto a low-performing device, so they had to make cuts somewhere. Yeah, and lastly, we just don't always have access to the devices. Sometimes we are scouring eBay looking for random Blu-ray players. Sometimes we've got it in storage and can't find it. Sometimes we've rang people like Sony and said, do you have this TV? And they don't anymore because they're just that old. I think we've been down to the DTG in London and used their Zoo for a device just because we don't have it. So that's a real pain point for us sometimes. Lastly then, key takeaways. So, number one, start by understanding your audience. That will help you determine what devices you need to support and therefore what technology. Secondly, consider the tensions of UX, cost and reach. Every new device comes with a cost. Every device you take on and want to release to comes at a cost, both to your UX and just to your engineering time and testing time and therefore release time. And then follow the 3 Cs. Compile your environment. Make sure devs are being able to use the kind of latest and greatest tools and technologies, but make sure it runs on TVs. Certify the runtime, not the application. Try and make sure that the browser you're running on is going to accept the application. And then configure your application. Allow those 2025 devices to fly whilst the 2013 is kind of stuck in the mud. And that is me. Shanika.